Welcome to the Python Programming Tutorial Series for Climate Mathematics, Theory and Applications, Chapter 4, Climate Matrices and Linear Algebra. In this video, we will create visualizations of the ENSO mode that was computed from an SVD method. Watch the linked video for more information on SVD.
Let's begin by setting up our figure to display the ENS modes. We are going to be accessing that matplot library, going in there and accessing the figure function. We are going to specify a fig size for our plot in order to be able to see all the details for our world map. Next, we are going to be using our base map package to put a cylindrical projection map onto our image. We're going to name this variable WMAP2. We are going to use the base map function with parameter projection equals cyl. This parameter does have a lot of options in the documentation for base map. Feel free to check out that documentation to figure out what these parameters indicate. The highlighted parameters are specifying our desired latitude values that we would like to see. We are going to be spanning from negative 90 degrees to 90 degrees in the latitude. For our longitude, we specify the entire longitude spectrum from negative 180 to 180 degrees. We are going to use resolution equals 2C. This just helps project our cylindrical map more evenly. Next, we are going to access that WMAP2 function that we just made from our base map, and we are going to use functions draw coastlines, draw parallels, and draw meridians. These three highlighted lines will put some detail onto our image. We are going to be able to see the coastline surrounding each country. We're going to be seeing the parallels of the longitude and latitude on our map, and we will also be able to see the meridian values. Next, we are going to add some data to our plot. First, this coordinate corresponds with Darwin, and this coordinate corresponds with Tahiti. So what these two lines are doing, accessing that scatter function in that matplot library, we are just going to have two dots displayed on our map indicating where Darwin is and where Tahiti is. Darwin will be in the color blue and Tahiti will be in the color red. This S parameter that is highlighted just dictates our pixel size. We are going to have a size of 150 on those pixels that are identifying these areas. Next, we're going to add some desired text to our plot. We are going to add Darwin negative 0.79 to our plot, very close to that scatter point that we just plotted. We are also going to add the Tahiti 0.61 text to our plot right above the point indicating where Tahiti is. And lastly, we are going to add some text saying El Nino Southern Oscillation Model 1, which is where we are getting these highlighted values for Darwin and Tahiti. Don't forget to wrap your whole block of code in a PLT show. Once we run this, we do get this beautiful world map to pop up. We can see that we do have parallels indicating longitude and latitude pairs. We can see all of our coastlines and all of our meridians. We do have Darwin indicated in the blue over on the right side of our plot, and we have Tahiti indicated in red near the left side of our plot. We can also see that we have our title on our map, and our title is the El Nino Southern Oscillation Model 1. Next, we are going to be plotting the El Nino Southern Oscillation Model 2 in a very similar manner. We are going to prepare our figure with that matplotlib figure function. We're going to go ahead and redefine WMAP2. Once we redefine WMAP2, it will override that WMAP2 that we used in the above block. We're going to once again access that base map function. We're going to have projection equals CIL, which is cylindrical projection. We're going to have our entirety of our longitude and latitude. The highlighted text indicates that we do want to see the entirety of the world map. Once again, we are going to draw coastlines, draw those parallels, and draw the meridians on our map. We are now adding the Darwin and Tahiti points. We are going to have both of our points come up in red, however, so it is quite important that we add desired text to these points. We are going to add our Darwin text. We are going to add our Tahiti text. Both of these lines are going to appear very close to their points. Then, lastly, we are going to add our title, which is El Nino Southern Oscillation Model 2. This is going to be in a color purple, indicated with an M. Lastly, just wrap your code with a PLT show function. Once you run that, you will get this map to appear. We can see that we have our Tahiti point on the left side of the map and our Darwin point on the right side of the map. Both points are in red, so it is important that we add those texts near them in order to indicate to the reader what we're trying to show them. In this plot, we are displaying the El Nino Southern Oscillation Model 2.
This concludes our section on visualizations of ENSO modes. In the next video, we will continue with Chapter 4, but take a closer look at multivariate linear regression using matrices.